Okay, so we can start. So, welcome everyone. My name is Joseph Gitau. I am a certified data science trainer and I do teach the machine learning and the deep learning units at Afric CDSA. Apart from that, I work as a financial analyst elsewhere. Yeah. So, today we are going to look at the intro to machine learning class. So, it won't be a practical session. So we will just be exploring the introduction part so that you can know what is machine learning, what are the different things we do in machine learning, and maybe what is needed for you to be good at fitting machine learning models. So you've covered the basics and now you are here at the advanced stuff. So what I would advise you is before learning machine learning in detail, you should first be good at the Python basics. So that's the only requirement that you need. I've shared this link with you. So it's a Notion link. It has the notes that we will be using for our classes each and every evening. And from these notes, you can see we have these. So if you open the link, we have this initial page that you are seeing over here. And in within that page, we have sub pages. So for example, I can open, so in the part for exploratory data analysis, I can open the cleaning and pre-processing link, and we have some more notes there that you can go through. I can go back to the main page and open another link. So this is where our notes are stored and you basically have access to it all. Yeah, so we will be using this Notion link to access our notes. So we are going to start the introductory part to machine learning. And as I have mentioned, today's class will be more of theory and we won't have any practical stuff to do today. So let's open the first page on what is machine learning and why is it important. So from the notes that I have written here, you can see that machine learning is a field of artificial intelligence that involves building algorithms and models that allow computers to learn from data without being explicitly programmed. So what does this mean? So you can think of these in simple terms as computers being given instructions. Okay. So these instructions are in different forms. And from these instructions, computers can learn from data what they need to do or what they need to extract from that data. So that's how we explain machine learning in simple terms. So machine learning is important because it enables computers to learn and improve automatically through experience. So once a computer has been given instructions, so it will learn from all the correct values it gets, and it will also learn from all the wrong values that they get. So these tasks enable computers to perform complex and time-consuming tasks that humans cannot do manually. So machine learning has a wide application, is applied in various fields. So for example, you can apply machine learning in healthcare. So if you are working at a healthcare center, you can use machine learning to assist you in making diagnoses. You can use it in finance, marketing, and transportation. So for transportation, for example, we can talk of Uber. So they use machine learning to figure out which is the shortest path and maybe which rider should we assign to these passengers. So it should be the rider that is the most closest or maybe with the highest rating. So you can use machine learning in marketing. So You can target customers that can give you the highest revenue return and all that. And again, I'll mention machine learning is not that much important as compared to the basics of Python part, because machine learning is just like 20, let's say 20% of the work that you will be doing. But exploratory data analysis is the most important thing that you will learn from this course. So we will have to revisit that. We can look at an example here. So for example, machine learning can be used to predict the likelihood of a patient developing certain disease based on their medical history and other factors, or to identify fraudulent transactions in a financial system. So it can be used to recommend products or content to users based on their past interactions and preferences. So that is on the marketing part, or to optimize routes for delivery trucks. So that's on the transportation part. So overall, machine learning has the potential to revolutionize the way we solve problems and make decisions. So by automating and improving processes that are currently done manually or using traditional algorithm. So that's just a short introduction as to what machine learning is. So we can do like a summary of what we've discussed here. So what is machine learning? So machine learning is a field in artificial intelligence, and artificial intelligence is just a combination of math, statistics, and programming, whereby you give computers instructions and you expect them to perform a task. Okay. And what does machine learning help you do? So it helps you automate your tasks mainly. Where can it be applied? It can be applied in any field. Let it be healthcare, finance, marketing, and transportation. All of them you can apply machine learning there. Then apart from that, we have the different types of machine learning models. So for the different types of machine learning models, I will maybe draw some examples here. And we can discuss from there the different types of machine learning models from the visualizations that we will have here. So we have part one there, we have part two. So this will be our main focus here. So for part one, let's say we have this drawing that I'm drawing here. So it's a kindergarten drawing, but definitely you'll be able to like distinguish what each image here represent. So for example, you will all know that this is a boy and this is a girl. Okay, so yeah, you will be able to distinguish that. Then we have, so this is our first set of data. So this is data one. Okay, then we have data two. Let's say something like this. So this field here. So this field has some X values, has some O values, and maybe it has some minus values. So this is our second set of data. So data two. So when we are working with data one, where we have labels, so these are what we call labels. So this is a data label. So what we do here is we feed supervised learning models. And in these cases where we have just random values which we don't know what they mean, we feed unsupervised learning models. Okay, so in machine learning, we feed supervised learning models to data that has labels. And then we feed unsupervised learning models to data that dot to datasets that don't have labels. So in simple terms, that's what we simply do. So if we go back to the notes, we can see what the notes are trying to tell us. Yeah. So here we have our explanation. So supervised learning. So we have different groupings of machine learning. So is a type of machine learning where the model is trained on labeled data. So which means that the data has known output or target. So the goal of supervised learning is to predict the output of a new unseen data based on the patterns learned from the training data. So if we come back here to our drawing and let's say we create another drawing. So this is our new drawing. So let's say it's somehow different from the others, maybe in terms of color. So what label would you give this drawing based on what you are seeing over here? So this will be girl, because already from the labels we can see that, for example, for girls, we have that distinct feature. So if you feed a machine learning model using this data that is here, you will be able to add labels to data that the model has not seen yet. So that's how supervised learning models work. So examples of supervised learning models include linear regression. So linear regression is used to fit regression models. Then we have logistic regression. Logistic regression is used for fitting classification tasks. So we will discuss them in detail. And we have support vector machines, so which are used for fitting regression models. Then we have unsupervised learning. So unsupervised learning is a type of machine learning where the model is not given any labeled data, and the goal is to discover patterns and relationships in the data. So if we go back to our plot here, so what are the patterns and relationships that we have in this data? So for example, if I change these, if I look at this box that we have here, so we have this group here, and what is the pattern that we are observing in that group? So this group has crosses in them, okay? And we have our second group here. And what is the trend or what is the pattern in that group? So they are all zeros. And we have this last group here. And what does that group show you? So it has only dashes. So what your model will do is that it will look at your data and create same exact circles that I've created over here. And when we will be doing our practical sessions, you'll get to see that. And an example of this model will be the KNN model or the K-means model. So we will see how we can apply those models to at least distinguish the different kinds of data that we have. Okay. So supervised and unsupervised learning is a type of machine learning where the model is not given any labeled data, and the goal is to discover patterns and relationships in the data. Examples of unsupervised learning include clustering, dimensionality reduction, and anomaly detection. So for dimensionality reduction and anomaly detection, we mainly use PCA and some other advanced models. So we will cover that also. Then we have semi-supervised learning. Semi-supervised learning is just a combination of supervised learning and unsupervised learning. So it is a type of machine learning that lies between supervised and unsupervised learnings. So it involves training the model on a dataset that has both labeled and unlabeled data. So the goal is to improve models' performance by leveraging the additional unlabeled data while still being able to predict the output for new unseen data. So we won't be looking at this because most of the time we usually use unsupervised and supervised learning models, but these can be applied when working with deep learning models. Then next we have reinforcement learning. So reinforcement learning, this is a type of model where there is a reward and a penalty. Okay, so if you do something good, you are rewarded. If you do something bad, then you are punished. So maybe I can create a sample illustration for this. So my drawings will be bad, but bear with me. So let's say here we have a dog, okay? And this dog has to make a choice. So for example, let's say there is a thief who came to your house. So the first action is to maybe chase the thief away or sleep. Okay. So if the dog chases the thief away, then we feed the dog. Okay. And if the dog does not chase the thief away and it sleeps, then we lock it up and give it no food. So what do you think the dog will do the next time a thief comes in? So it will definitely follow the fast path. So it will definitely follow this path where there is a reward. So this is a reward. Okay. So what reinforcement learning models do is they follow the path with the maximum reward and avoid the path with penalty. Okay. So that's what reinforcement learning models do. And in this course, we won't cover that because it's an advanced topic and it requires you to be both good at Python programming and both good at these other basics parts, which is the supervised learning and unsupervised learning part, which we cover in our course. So reinforcement learning is a type of machine learning where an agent learns to interact with its environment in order to maximize a reward. The agent receives feedback in the form of positive or negative rewards and uses this feedback to learn the best action to take in different situations. Example of reinforcement learning includes autonomous robots and game playing agents. So each type of learning has its own unique characteristics and applications, and choosing the right type depends on the nature of data and problem at hand. So when we start the practical sessions, I'll guide you on how you get to choose which kind of model you need to fit to your data. So based on the data that you're working with. Yeah, any questions concerning what we've looked at so far? Okay, so I know the first session will be boring because it's all theory. Yeah. Anyone with a question? Okay, so if you don't have questions, we can look at the common applications of machine learning and then we can stop there for today. So yeah, let's look at this. So machine learning has a wide range of application in various fields, some of which include healthcare. So in healthcare, machine learning can be used to predict the likelihood of a patient developing a certain disease based on their medical history and other factors, or to identify patterns in medical images that may indicate a certain condition. So doctors can use scans and they can feed ML models to these images of scans and they will be able to like predict if a person is likely to get cancer or not. So it can be used to optimize treatment plans and to improve patients' outcomes. Then in finance, machine learning can be used to identify fraudulent transactions, predict stock prices or credit risk, or to optimize trading strategies. So I believe Xavier, one of your trainer, works at Beryl and he was able to like inform you that he most likely uses machine learning to like group customers into different credit risk categories. Okay, so that's one of the application of finance. Then we have marketing. Machine learning can be used to personalize recommendations to users based on their past interactions and preferences, or to optimize advertising campaigns based on target audience and performance. Then we have transportation. Machine learning can be used to optimize routes for delivery trucks or ride sharing services, or to predict maintenance needs for vehicles. We have NLP, which is natural language processing. Machine learning can be used to analyze and understand human language, which has applications in speech recognition, language translation, and text analysis. And lastly, we have computer vision. Machine learning can be used to analyze and interpret images and videos. So this is just like the Tesla vehicles, which can be able to like self-drive themselves. So which has applications in object recognition, facial recognition, and automated surveillance. So these are just the few examples that we have here. So as we proceed on with our classes, we are going to look at more ideas on how we can apply machine learning to real world data. Yeah, so I will request we stop there for today. You go through this introductory part and familiarize yourself with the note platform I'm using, that is Notion. And then what I will require you to do is maybe create a folder where you will be writing your ML codes. Yeah. And most of the times I will require you to be connected to the internet, because the datasets that we will be loading will be hosted on GitHub. So I'll just be sharing links and we can be loading the dataset directly from our notebooks, which will require you to be connected to the internet. Yeah. So anyone with a question? Okay, so I've shared the Notion link in the WhatsApp group we have. So what I'll do is I'll add that to the group description also, so that you can have access to the notes anytime you want to go through them. Then again, I'm going to create a Google Drive folder where I'm going to upload all the class content or all my notebooks and data. So this will be ML May intake. Then I'll give you all access to this folder so that you can have access to any resources that I'll be uploading here. Yeah. Anyone with a question concerning what we've covered today?